Myself, Dr. Mohan Kumar, TP, working as an assistant professor in Government First Grade College. Presently, I'm going to discuss about the topic called bivariate analysis, which comes under research methodology. There, bi means two. When we are using more than one variable within the restrictions of two variables, it means variable means the factors. Say, for example, age is a variable, height is a variable, income is a variable, like that. So, if we use two variables at a time for your data analysis, then that analysis is called bivariate analysis, and which comes under, with the help of cross tabulation and chi-square, we can analyze the bivariate analysis. Okay, so far the statistical methods which we have been using only permit us to look at the frequency in which certain numbers or categories are occurred. It means the analysis which comes with number of category which we use. Say, for example, if we use one category or one variable, we use the statistical analysis called univariate analysis. And if you use two variables at a time for our analysis, then that analysis is called bivariate analysis. Look at the measure of central tendency, such as means, modes, and medians for one variable, that is univariables. Look at the measures of dispersion, such as standard deviation and z-scores for one interval or ratio level variables. So, bivariate analysis, it involves two variables. It deals with causes or relationships. Major purpose is to explain one of the simplest forms of the quantitative statistical analysis. Quantitative, the terminology itself explains quantitative means it is numerical in nature. It is not a qualitative data, it is quantitative data. It can be measured in terms of heights in centimeters, okay, square feet, or it can be in terms of the, say, for example, quality, that is the quantity. Say, for example, 10 liters, 100 liters. If it is in a liquid form, will be measured with the help of liters, gallons. So, bivariate analysis allows us to look at the associations or relationships among two variables. Say, for example, in univariable analysis, we use only one category or one variable, single variable. So there is no scope for to measure the associations or relationship because it is one variable. But as and when we are using two variables, it helps to understand the association between two variables, or it helps to understand the relationship between the two variables. Look at the measures of the strength of the relationship between two variables. What is the strength? What is the weakness? What is what? And what makes it right and what makes it wrong? So the followed by test hypothesis about relationship between two nominal or ordinal level variables. For example, what does this table tell us about the opinion on welfare by gender with this below mentioned table? Okay, support cutting welfare benefits for immigrants, male, with the categories like male and female. Okay, supporting cutting welfare benefits for immigrants, male 15, female 5. Okay, then it also indicates how many of them they have taken the benefit, welfare benefits, and how many have not, they have not taken the benefit. It's followed with 15 male. Okay, 15 males they have taken the benefit, welfare benefits, and 10 they have not taken the benefit, welfare benefit, like that. In followed by female, that is 5 yes and 20 no. The total population for this particular study is 25 male and 25 female. So total population for this study is 50 population, we call it. Rules for cross tabulation. Calculate either column or row percents. And calculations are the numbers of frequencies in a cell of a table divided by the total number of frequencies in that column or row. For example, the total population is 25, the cell number is 20, then automatically we'll convert it into percentage, that is 20 divided by 25 multiplied by 100, we can get it in percentage, that is 80%. All percentages in a column or row should total 100%. It means the number may be 10, the male is 10, female is 10. The total percentage has to be 100%. It should be in row or it should be in column. It has to make 100%. Okay. Then let's look at another example, social work degrees by gender. So how many people they have awarded with social work degree? That is BA, MSW and PhD. In that, the BA male is 20, female is 20. The total population here is 40. So among the 40, 33% are male and 20% are female. Okay. In the same way, MSW, that is 30 are male and 70 are female. Luckily, we can count it, it comes to 100. So automatically 30% are male and 70% are female. Like that, PhD. So total 10 people have awarded with PhD degree, male, and 10 again female candidates have been awarded with PhD. So automatically it comes to 16.7% and 10%. So it means to say, so among the total population with the male 20, 30, 10. So total it comes to 60. So 60 is 100%. If it is 60 is 100%, then automatically 20 is 33.3% and 10%, 10 population, it comes to 16.7. So this and this, the first 33 plus 16, it comes to 39 and 49 and it comes to 50. So that remaining 30 becomes automatically 50%. So like that, female 20, 70, 10, it comes to 100%. So in that 20%, 70%, 10%. So it means the whole, it has to be 100%, especially in the population. Male is 100%, female is 100%. Among that, how many people have awarded with BA and how many people have awarded with MSW and PhD degree? We use cross tabulation when we want to look at relationship among 2 or 3 variables. If you see earlier in bivariable analysis, we use only 2 variables. There is a restrictions with 1 variable, means it is automatically we claims that univariables. If it is more than 2, it is multivariables. So we use for cross tabulation, we want to look at relationship among 2 or 3 variables. We want a descriptive statistical measures to tell us whether the differences among groups are large enough to indicate some sort of relationship among variables. So what is making the result positive or negative? Who is strong and who is weak? And what makes them to be strong and what makes them to be weak also, it is easy to measure with the help of cross tabulation. Cross tabulations are not sufficient to tell us the strength or actually size of the relationship among 2 or 3 variables. See, sometimes what happens in a simple analysis, it is easy. But when it comes to the complex one, it is very difficult to measure what exactly the relationship among the 2 or 3 variables. And test a hypothesis about the relationship between 2 or 3 variables. To understand better, then we form hypothesis and to test the relationship between 2 or 3 variables. And tell us that it automatically, that cross tabulations tell us the directions of the relationship among 2 or more variables. Look at the relationship between one nominal or ordinal variable and one ratio or interval variables unless the range of possible values for the ratio or interval variable is small. Then what do you think a table with a large number of ratio values would look like? That is the reason we can use cross tabulations to visually assess whether independent and dependent variables might be related. In addition, we also use cross tabulations to find out if demographic variables such as gender and ethnicity are related to the second variable. Independent means it is not depending on any other factors to show their values. But when it comes to dependent variable, the result or outcome, it is based on other variables. I hope I'm reaching you. Then you must use an additional statistics, that is chi-square, if you want to test a hypothesis about two variables. If you want the specific and specialized, and if you want to go in detail, you need to test a hypothesis about two variables. Look at the strength of the relationship between an independent and dependent variable. Determine whether the relationship between the two variables is large enough to rule out random chance or sampling error as reasons that there appears to be a relationship between the two variables. So this is the reason we use the hypothesis testing. Chi-square is simply an extension of a cross tabulation that gives you more information about the relationship. However, it provides no information about the direction of the relationship, whether it is positive or negative. Whether it is positive or negative between the two variables. The positive relationship means in an X and Y curve, okay, the line goes from left to right, wing, okay. It is positive correlation. And it is negative means through X and Y, it goes upward from right to left. Hypothesis testing. Goal makes statements. Say, for example, goal makes statements regarding unknown population parameter values based on sample data, elements of a hypothesis test. When we are testing an hypothesis, there are major elements. The first element is null hypothesis. Statements regarding the values of unknown parameters typically will imply no association between explanatory and response variable in our applications will always contain an equality. Alternative hypothesis, statement contradictory to the null hypothesis will always contain an inequality. It disproves, as in when it is not approved, so there is a scope for alternative hypothesis. That is, that statement contradictory to the null hypothesis will always contain an inequality. The test statistic, quantity based on sample data and null hypothesis used to test between null hypothesis and alternative hypothesis. The last one is rejection region, values of the test statistics for which we reject the null in favor of the alternative hypothesis. Thank you very much for watching this video. Thank you once again.